This short video is a demonstration of some of the basic facilities available in CFView. We're going to make a map plot with some contours on it, a vertical plot through the atmosphere, a vector plot on a map, and a line plot, as in a graph plot. So let's get started by loading in a dataset CFView. So CFView data.nc. Here's the interface to CFView, and in the top left you can see that we've got one field with an index number of 0. We've got 192 x elements in it, as in longitudes, 144 y latitudes, 19 vertical levels, and 165 times. And in the bottom right you can see that we can see our dimensions. So we're selected on X at the moment, and we go from 0.93 degrees around the world to 359 degrees. And in latitude, or Y, we're going from near the South Pole up to near the North Pole. And in terms of Z, we're going from 1,000 or 100,000 pascals, which is roughly 1,000 millibars, as in the surface of the Earth, going up to 100 pascals or 1 millibar near the top of the atmosphere. In terms of times, we're going from 1850, July the 1st at 6 o'clock in the morning, until 2014. Again, all of these dates and times seem to be in July. 1st of July at 6 o'clock in the morning, so they're probably a yearly mean, because that's the midpoint of the year. So let's make our first plot. So here we've got a drop-down menu. It's set at contour by default and XY, so we're going to make a map plot, and so here we go. Let's do a plot, and our field is air temperature, so it goes from 235 Kelvin up to 300 Kelvin, and you can see we're looking at 1,000 millibars and the first time step. So it selects all the items are selected initially in the dimension lists. So the first one, because it's an XY plot, our first time is the one that's selected, and our first level that's selected is 1,000. So you can see that there's some missing data here. This is where the orography is masking the data. So you can see that in the southern hemisphere, Antarctica is blanked out white, because that's higher than 1,000 millibars, and also it looks to be some ice going around our model at the bottom here. So let's just change our vertical level. Let's select 925 millibars and make a plot there instead. And so you can see that this is conforming much more distinctly to the coastlines. So you can see the Andes, Greenland, and Antarctica down here with masked out data. So that's making a map plot. And one of the features in CFView is that it outputs model code as it goes along, so you can actually see the code that you would need to run this in a Python script or just on the Python command line. So what we're going to do is we're going to copy and paste that over. So let's start up IPython, and let's copy the code here. There we go. And on the command line we've got exactly the same plot using the code that was produced within CFView. So just looking quickly at the code that is needed to make that plot. So there's 5 lines. We've got 2 imports. So the import CF is importing CF Python, and then we've got CF plot imported as CFP. That's the handle for it. Then we're going to read in our data set, so it's our first element, so that's bracket 0 brackets. And we're going to do what's called a subspace method using CF and we're going to select Z is 92500 and some nice long digits there. And also we're going to select our time, and that's at the time stated as a time string, but then we need to use the CF method dt on that to actually convert it to a number that CF Python can understand. So that's our data set. So now this is a 2D data set, and then we can pass that through to CFplot, so cfp.con on our f variable, and we're going to turn the lines off on the plot off, and also say that we would like some titles to say what dimensions we've got on our data. So that's our first example of making a map plot. So let's reset our dimensions, and let's try making a YZ plot. So we change that, the contour method, to be YZ, make a plot, and you can see similar plots through the atmosphere, and you can see that we go from 90 south to 90 north, and we're going from the surface of the atmosphere 1000 millibars up to sort of 5 or 3 or something like that millibars up at the top. You can see that Antarctica is blanked out and white. It's quite high up there, and there's also some blanking out in what's presumably the Himalayas, that sort of area over there. And we can also select a different thing. We could do something like a time versus Y plot, and you can see a similar thing. So we've got time along the bottom axis there, and in years, and we're going from the South Pole to the North Pole-ish, and so we've got missing data over Antarctica as before, and some in the northern hemisphere as well. So that's it for contour plots. So let's load in a different data set. This one is called ggap.nc, and we're going to do a different plot here. So in this drop down, you can see that there's vector, contour and vector methods available, as well as line and trajectory plots. So let's select a vector plot, and we're going to do a x versus y plot of vectors, and our x index for the vector we're going to use eastward wind, so that's number 7. And our y vector is the northward wind, which is the next one down, that's number 8. And we're going to change our pressure level, so we're going to go at 500 millibars for the eastward wind and 500 millibars for the northward wind. So let's make a plot, and you can see that there's a map underneath there, but there's a lot of black because our vectors are very dense, so there's a lot of little vectors drawn on there. But if you look up on the titles, you can see that the pressure is 500 millibars from both of them, and our time selected is the same time. So it's important to note that. So let's change our vector density. So if we go into the setup vectors drop down panel, we can stride through. Let's stride at every 4, plot every 4th vector. And there we go, got a much nicer plot of the same data. We've just skipped and plotted every 4th vector. We've also got a little vector annotation down here showing you how big 10 meters per second is. So our final example is going to be a line plot. So let's reset our dimensions and go back to air temperature, and we're going to select a line plot for this field, and we're going to go along x as in longitude we're going to select something like 66 north, and we're going to select 925 millibars and click plot. There we go. So we've got longitude along the bottom with the appropriate labelling of east and west, and the vertical axis is air temperature, and we can see that we're at 66 north and 925 millibars. So that was just a quick view of CFView and making some initial plots of our data. Other videos available in this series will be transforming your data, as in doing things like zonal means or regridding, viewing the data as in the actual data points as to what the values are in a tabular format, viewing and changing and adding new properties, and selecting and modifying and saving data. Thank you for listening.